Bismillahirrahmanirrahim. Assalamualaikum. Alright, in this video, we will look at the volume by the last method in this chapter, which is the cylindrical shell, or sometimes we call it as shell method. So we should divide this type of volume into two parts. Alright, so the first category, which is the rotation about vertical axis, which is parallel to y-axis, and another one which is the rotation about horizontal axis, which is some horizontal line, which is parallel to the x-axis. Alright, so let's look at the first one. So bear in mind that this type of volume, all right, so this method of volume is completely different from the washer method and also the disc method. All right, so now please take note that when we actually rotate about vertical line, it should be dx, right? So it should be 2 pi, volume should be given by 2 pi, integrate radius multiply with height, and it should be dx, not dy. Difference between this method to get with the what we call washer or this method, in this or washer, when we rotate about vertical line, it should be dy, but in this method we should write in terms of x, dx, right? That's the first difference. So for the radius, okay, we'll look at it later, all right? So but for the height, we should write the top function minus the bottom function, right? For example, suppose we have this one. Okay, so this is the function we have. This is the region, the green region that we want to rotate about. Line x equal to r. So this is the axis of rotation. So what we have to do is to define the formula for volume. So volume is given by 2 pi integrate, all right? So integrate when we know that it is rotated about the line which is vertical, so it should be dx in this case. All right, so we know that it should be radius multiplied with height. All right, because it is dx, so we should look the values on these integrals should be on x-axis, which is given by a and b. So you should write a and b here. All right, so now we have to determine the radius. So the radius in this case is actually this one. All right, so this is the radius. Sorry, this is the yes, this is the radius, right? So this is the radius, and this is actually the height. Right, so in this case the height is actually the top function minus the bottom function. So the top function is actually fx minus the bottom function y equal to gx. So we should write the height is actually given by fx minus gx. Right, so this is in general functions, but for the radius, all right, so we know that it is in terms of x, so radius should be, all right, so you look at the axis of rotation. If the region at the right side of the axis, so the x minus that axis, which is x minus r in this case, right, x minus r. But in some cases, when you have the region which is somewhere around the left side of the axis, suppose this is the axis, right, which is x equal to r, so the radius in this case, so this is the region that we want to rotate about this line. All right, so we should note that for this type of what do we call for this type of function, all right, for this type of region, we will have to what do we call it, sorry, I don't know why this one coming here. All right, so we should note that in this case the radius should be given by, all right, so the axis, which is r minus, all right, x, r minus x, right? So for this case x minus r, all right, so for this case x minus r. But if the region at the left side of the axis, so it should be r minus x. All right, so that is for the first one. Let's look at the second one, which is the rotation about the horizontal line. The horizontal line is actually parallel to x-axis. If it is in disc or washer method, we should note that when we rotate about horizontal line, we should write the volume in terms of pi, integrate that one should be, you know, when it is rotated about x-axis, so it should be dx, and it should be top minus bottom. But it is different here, right? For the washer method, it should be something like this, right? So you should start your formula for volume, which is given by 2 pi, integrate radius multiply with height, but bear in mind that when you rotate about the horizontal line, so it should be dy. It is completely different from the washer method, all right? So 2 pi radius multiplied with height dy. Okay, so for this case, the height will be defined as the right function minus the left function, right? So let's look at this example, right? So this is the region that we want to rotate about the line x equal to r. So now we know that the volume for volume, which is given by 2 pi integrate in terms of y now. All right, so the values on this integral should be on y-axis because it is dy. All right, so on y-axis, so the region is bounded from a until b, so you should write a and b on this integral. Right, so we know that we have to use the formula which is r multiplied with h, which is radius multiplied with height. So I would like to define the height first. In this case, we should look at this because the height should be defined as right function minus the left function. In this case, the right function which is given by this minus the left function which is given by this, all in terms of y right now. So fy minus gy. So fy minus gy is the height. But what about the radius? Now we're going to look at the radius. All right, so now we have something like, of course it should be in terms of y. All right, so this is the height, which is right minus left, and this is the height. Sorry, this is the radius. All right, I'm talking about the radius. So this is the radius, where the radius in this case, all right, so you know, something like because the region is at the top of the axis, so it should be y minus the r, which is y minus the axis. Right, if the area which is below the line, suppose like this, so this is x equal to r, so the radius should be, all right, this is another case, the radius should be the r minus y. All right, so this is completely different from this one. All right, so which is something like this, or later on we will look at some examples. All right, so we will look at some examples, but before we look at the examples, I would like to explain a little bit why the height and radius something like this. Suppose we have that region, right? So now we want to rotate, all right? Something like this. Okay, we have this region, right? So this is the region. Now we want to rotate about this line. Suppose we want to rotate about this line, all right? So when we rotate about this line, so it will be something like this, all right? So something like this, right? So it will be something like this. Right, all right, so this is the shape that we have. All right, so this is the shape that we will have. So please take note that when we have something like this, because this is the solid that is formed when it is rotated. All right, so of course this is the height. The height should be, all right, something like this, same as this. All right, and the radius of this should be something like this. All right, so the radius of that what do we call of the solid, right? Something like this. So the xy, it is something like this. Okay, all right, so let's look at some examples. Right, suppose we have this first question here. So we want to find the volume using the shell method when the region is rotated about y equal to -2. So we should determine, is it vertical or horizontal? So we know that y equal to -2 is actually a horizontal line, which is something like this. So this is the axis of rotation, all right? So when we know that in shell method, when we want to rotate about the horizontal line, right? So the formula should be in terms of y, all right? So it should be dy in this case. And we know that we have the radius multiplied with height. And the value on this integral should be on y-axis because this is dy. So on y-axis, the region is bounded from, all right, so you look at that, -2 until 1, all right? So -2 until 1. So it should be -2 until 1. All right, so now you have to determine the radius, all right, and the height. And we know that when it is in terms of y, it should be right minus left. So the right function is actually this one, right? So let's look at the right function. Of course, this one is the right function. We should write in terms of y now. So we have to modify this equation in terms of y. So it will be something like x equal to 1 minus y squared will be the right function. And the left function is given by this line, which is given by that equation, where we have to modify it to be x equal to y minus 1. Yes, okay, so we know that we want to take this function y1 minus y squared, which is at the right. So that is the height, 1 minus y squared at the right. We should subtract the one at the left, should be this function y minus 1. All right, so y minus 1, please put it in the bracket. We have to simplify this one, should be 1 minus y squared minus y plus 1. All right, so it should be 2 minus y square minus y. Right, so that is for the height. Now you should look at the radius. We know that radius, it should be something like this, right? It should be something like that. So the radius is something like this. So you know that the region is, at the top of the axis. So it should be the x. Sorry, it should be in terms of y. Y minus the axis. The axis is actually y equal to -2, right? So y equal to -2 is the axis. So you should take y minus -2. So y plus 2 when you simplify this, right? So now you want to take into the formula, right? So substitute inside the formula, it should be -2 until 1. The radius, it should be y plus 2. And the height should be 2 minus y square minus y dy. Right, that is the construction for the volume. So what you need to do next is to expand this function, and then you integrate and you get a final answer. You can leave your final answer in terms of pi, right? So I'm not going to show everything here, so you should do on your own, right? So this is how you construct the formula for volume for the washer method, shell method for this one. All right, so let's look at this one. Right, so now we want to rotate about x equal to -1. So the first step is that when you are given a question, you look at the rotation, at the axis of rotation, and you go to that axis. Right, x equal to -1 is somewhere around here. Right, so this is x equal -1. We know that it is rotated about vertical line. So when it is rotated about vertical line using the shell method, it should be, right? It should be, the formula should be in terms of y. Sorry, in terms of x, dx. All right, so we know that when it is rotated about the vertical line, it should be dx. So r multiplied with the height. All right, sorry, r we multiply with the height. All right, and the value on this integral should be on x-axis. So you look at the region, all right, where it is bounded on the x-axis from 0 until 2. So you write 0 and 2 on this integral, right? So now your task is to find the radius and the height. So for the radius, all right, I'm gonna hold for the radius. We look at the height. We know that when it is in terms of x, the height should be the top function minus the bottom function. So in this case, you look at the region. So this is the top function, which is given by, all right, now we want to write in terms of, we want to write in terms of x. So it should be, right, you have to modify this function, y equal to 6 minus x. So that is the top function. What about the bottom function? The bottom function is given by y equal to x squared. So we know that the top function is 6 minus x. So the height 6 minus x. We should subtract the one at the top, at the bottom, it should be x squared. Right, that is for the height. But now you have to look at the what we call that, the radius, right? So the radius is something like this. All right, so we know that, all right, so when the region is at the right side of the axis, so that should be x minus the axis. So x minus the axis is actually -1. So x minus -1. So this should be x plus 1. Alright, so we have obtained the radius and height. So now we can substitute inside the formula for volume. So it'll be something like 2 pi. We now integrate from 0 until 2. Alright, radius should be x plus 1. And the height should be 6 minus x squared. It is dx. We know that everything should be in terms of x now. Alright, we don't have any terms with y. We don't have that. Right, so now that's it. I hope you're okay with this one. So what you need to do is to expand this one, and you find the integration for each term, right? So, and substitute with values from 2 is from 0 until 2, and you get a final answer. You can leave your final answer in terms of pi. All right, so let's look at the third one. All right, so we have something like this. Now we want to use the shell method, and we want to rotate about x-axis. So I'm gonna highlight the axis of rotation should be something like this. So we want to rotate about this. We know that when we want to rotate about the the horizontal line, it should be dy. All right, so for this shell method, and the volume should be, the formula should be radius multiplied with height. When it is dy, we know that the value on this integral should be on y-axis. So look at the region where it is bounded. Of course, from 0 until 2. Right, so that is the bound, right? So upper bound and lower bound of the region, right? So from 0 until 2 on y-axis. Why it is on y-axis? Because now the function in terms of y, right? Okay, so now you have to look at the height. So we know that when it is in terms of y, it should be right minus left, right? So right minus left. So the right function is given by this. Alright, so that is the right function, which is 2 minus y squared, and the left function should be given by that, which is x equal to negative y. So we want to take this, so the right, which is 2 minus y squared, so you write 2 minus y squared, you subtract the one at the left, which is negative y. Alright, so you simplify this one, should be 2 minus y squared plus y. That is your height. Now you should look at your radius, right? So because the axis of rotation is that vertical line, so it should be, all right, so the radius should be something like this, right? So because the region is at the top of the axis, so it should be y, all right, in terms of y, right? Y minus the axis, which is 0, right? So y minus 0. Y should be minus 0 because this is the line y equal to 0, right? All right, so yes, y minus 0 should be y. Okay, now we have obtained the radius and the height. We can substitute inside the formula. So volume should be 2 pi, integrate from 0 until 2, right? All right. So radius, which is y, and the height should be 2 minus y squared plus y, dy. Alright, so what you need to do is to expand, alright? So you have to expand this one, and then you have to integrate and get a final answer in terms of pi. Alright, so that's it. Alright, so let's look at question number 4 here. We want to use the shell method to find the volume when the region is rotated about the x equal to 2. So I'm gonna draw the line x equal to 2, which is given by this line, right? Alright, so this is x equal to 2. So x equal to 2. So we want to rotate about this axis. So it is a vertical axis. So the first step is to determine, is it dx or dy? So the volume should be in terms of x, right? Because it is rotated about the vertical line, so dx. And the volume should be given in terms of, r multiplied with h, radius multiplied with h. And what about the values on this integral? Because it is in terms of x, so we should look on x-axis. So look at your x-axis, where the region is bounded from, alright? So look at this, from 0 until 2, from 0 until 2. So you write from 0 until 2. Right. So your next task is to find the radius and the height. So the radius, all right, I'm going to look at the height first. Because it is in terms of x, so the height should be the top function minus the bottom function. So this is the top function, and this is the bottom function. So 4 minus x squared. Alright, so that is the top function, and minus negative 2x plus 4, minus negative 2x plus 4. Alright, so this is the height, so we expand that negative, alright, so to be 2x minus 4, so 4 minus 4 should be 0, so 2x minus x squared. Alright, so that is the height. Your next task is to find the radius. Alright, so the radius should be something like this. Alright, this should be the radius. Alright, so but now you look at your region. Your region at the left side of the axis. So in this case, the axis, which is 2 minus x. Is it x or y? It should be x. Why? Now all our functions in terms of x. So it should be 2 minus x. Right? That is the formula for radius. So 2 is the axis. Why? You have to take 2 first, not x, because the region is at the left side, right? So this is more right, right? So the axis at the right side, so 2 minus the x. Okay, so that is your radius. So you have obtained the radius and the height. You can substitute inside the formula for volume. It should be 2 pi, integrate from 0 until 2. 2 minus x should be into the bracket, and the height should be 2x minus x squared should be into the bracket, dx. What you need to do next is to expand this function, and you can find the integration for each term, right? So final step is to substitute with value from 0 until 2, and you get a final answer. in terms of pi. All right, so that is for question number 4. Let's look at question number 5. All right, so we want to rotate about y equal to 2. Y equal to 2. Okay, this is the axis of rotation. We want to rotate about y equal to 2. All right. Okay, so y equal to 2. Okay, so it is rotated about the horizontal line. We know that when it is rotated about horizontal line, the volume should be in terms of y now, right? So dy, because it is shell method, all right, not dx. Don't misunderstood. Understand this together. Don't interchange together with that volume or washer. All right, don't get confused by that. All right, so dy, and we know that because it is dy, the value on this integral should be on y-axis, which is the region is bounded from -2 until 2 on y-axis, -2 until 2, right? And the volume is given by the formula r multiplied with h. So you have to find the height first. The height in this case, because it is in terms of y, should be right minus left. So the right function is actually x equal 1, and the left function is actually given by this, which is right. Okay, given by this, you have to modify. It should be x equal to y squared over 4. So the right function minus the left function. So 1 minus y squared, 1 minus y squared over 4. That is our height. So now you have to find a radius, right? So the radius should be something like this, all right? So this is the radius. So look at your axis. Is it the region below or the top of the radius? Axis. Now the axis is at the top of the region. So now we should have y equal to 2, right? So 2 minus y. Why is it like this, not y minus 2? Because the region is below the axis of rotation, all right? So that is the reason. So now we substitute inside the formula. So v is equal to 2 pi integrate from -2 until 2. So 2 minus y, 1 minus y squared over 4 dy. And then you expand this function, right? So you expand that, and then you have to integrate and substitute value from -2 until 2, and you get a final answer. All right, so that is for question number 5, and let's look at the last question here. All right, so okay, so now we want to rotate about y-axis. All right, suppose this is the y-axis, so this is the axis of rotation. We want to rotate that region, so we know that it should be dx, right? So it should be dx, and the formula should be given by r multiplied with h, right? So the value on this integral should be on x-axis because it is in terms of x. So on x-axis, you should look at the region. It is bounded from this part, which is 0 until, all right, 3. From 0 until 3, right? So from 0 until 3, right? So the height should be the top function minus the bottom function because it is in terms of x. So the top function is, of course, this one given by x, and the bottom function should be this one, which is given by x squared minus 2. So x minus x squared minus 2x. Okay, all right. So you have to expand that one, right? So the height should be x minus x squared plus 2x. So of course you should have 3x minus x squared. And the radius, what about the radius, right? So that is the region. So the radius should be something like this, because the region is at the right side of the axis. So it should be x minus the axis of rotation, which is 0, because the line y equal to 0. Okay, all right. So that is x actually. Okay, so now you want to substitute inside the formula for volume. 2 pi integrate from 0 until 3, right? From 0 until 3. Cannot move this one. Okay, so 3x minus x squared dx. How do you decide if the formula is true? So it should be in terms of x. So it should be, everything should be in terms of x, and these values also in term on the x-axis. All right. and then you can expand that and find the integration and get a final answer. So this is basically the shell method, right? So we have completely done. We are completely done with the calculus one. So I wish you all the best for the final assessment. Thank you for watching.